Hello dear students, again welcome back to our discussion on statistical quality control and control charts. So in this session I wish to have a tutorial session actually. We can discuss on two problems related to X bar and R chart. So before going to that we can have a quick review on two control charts and all. So to start with the control charts for variables we actually did, which are useful for controlling fully automatic processes where the operator is probably responsible for 3 or more machines. Control charts for fraction defective and defects per unit are attribute control charts that we already told, like whether you can count it or not, whether you are having a continuous or discrete data. A fraction defective control chart discloses erratic fluctuations in the quality of inspection, which may result in improvement in inspection practice and inspection standards. So a brief comparison that you can see, variable chart and attribute chart. You can see example X bar R chart, NPC chart for attribute. Type of data required is variable data, and just read along what we already discussed, like those things are being given in the comparison. The material you can find in our ERP Linways. You can see the material, you can download it and read along, and you can clearly find out the differences between a variable chart and an attribute chart. So how you are going to select a control chart, whether it mainly depend on whether you are having a variable data or attribute data. And if you are having variable data, what is the subgroup size, that is sample size, what will be the sample size? Based on that you will be actually taking whether you need to go for X bar and R, X bar or S, I and M R chart. So for your particular syllabus you need to we need to discuss only on X bar and R chart, and you can see that the subgroup size for X bar and R chart will be between 1 and 10, that we previously discussed the problem. Also our sample size was 4, that lies between 1 and 10. And if your n sample size is above 10, then we will be going for X bar and S. S is actually based on standard deviation and all. And another type is there, if n equals 1, only one sample you are having, you have to go for I and MR chart. And based on your if you are having an attribute, counting defects or defectives, based on that you will be having two type of things. If you are having counting defectives, if your sample size is constant, you will be having NP chart. If your sample size is not constant, then you are having P chart. If you are counting on the defects, if you are having same type of opportunity to find a defect, then you have to use a C chart, or else you have to go for a U chart. Anyway, our discussion will be again limited to X bar and R chart. X bar and R chart. Okay, so we can go to the problem. Say here a data is given to you. The following collection of data represents samples of the amount of force applied to a gluing process. Determine if the process is in control by calculating the appropriate upper and lower control limits of X bar and R chart. So we can give a try to find, you can give a try to draw X bar and R chart. So now definitely you can have a notepad with you. Now we are having some 15 samples with you. Each sample will be having some 5 observations. You can say for example your first sample, your first observation, second observation, third observation, fourth and fifth observation. We are not bothered about the unit and all, because we are having only data where you are having some force is being given. So I am not telling you that it is in kilogram force, Newton, nothing like that. Everything given is in is force. So for the first sample you can see that value is 10.68, 10.689, 10.776 and 10.798. So for that sample, for to have an X bar and R chart, what you need to do is, for each sample you need to find out X bar and R, and for entire sample you need to find out your X double bar, or the average of average and your average of a range. So what I can do is, it's easy to draw two more columns on the right side. So first one will be X bar, that is the average for each sample, and the second column will be my range. So range can be calculated like, it is maximum value minus minimum value in your particular sample. Okay, so going to that, I can show like this. So I am extending my table. I am extending like on the right side I am inserting a new table, that is average, that is showing X bar, and one more the thing, that is the range, that is your maximum value in that particular sample minus minimum value. So I am finding average and range for each and every samples, and I am having say 15 number of samples. So for 15 number of samples I am taking the average of average and average of range. So my average of average, or X double bar, which will be my center line in X bar chart, and R bar, which is my center line in R chart, my values are X double bar is 10.728 and R bar is 0.22 point something. Yeah, okay. So this is the thing that is required, the thing required for going up to going for my R bar and X double bar chart, or simply X bar and R chart. So now I need to know, before for drawing my chart, I actually need to know my UCL and LCL values, that is upper control limits and lower control limits for both X bar and R chart, right? So to find that, I need to go for my normal distribution table. So my sample size, now my question, I am having say 15 samples. My table is this one. I am having 15 samples, sorry. I am having 15 samples, and I am having 5 observations in each sample. So now that I got my X double bar and R bar, definitely from normal distribution table, for X bar chart I need to get the value for A2. For R chart I need to get the data of D3 and D4, the values of D3 and D4. Then only I can compute in my equation, because I already show you, we already did a problem where your equations that we discussed were this one. So UCL of X bar is X bar plus A2 into R bar. X double bar and R bar we already have. For UCL for R it is D4 into R, so D4 value I need to know. LCL of R I need to get D3 into R bar. So we need to select it from our normal distribution table. So based on what? Based on number of samples, or based on number of observations in each sample? So it should be based on the n value, where n is your number of observations in each sample. Okay, n should be the number of observations in each sample. So here we are having 15 samples, and in our case here all the samples are having 5 observations. So we need to take the value based on n equals 5. Already if you again go to our equations, you can see that our X double bar and R bar is defined based on G, small letter G, where G is actually the number of samples you are having, not the number of observations. So here if you are having n equals 5, that is our case in the given problem, where for n equals 5 you are having A2 is 0.58, D3 is 0, and D4 is 2.11. So based on that we are actually calculating your UCL and LCL. Please compute the values. Please take your notepad and compute the values. Find out the UCL, find out the LCL based on A2, D3 and D4 that we found out. Find out the UCL and LCL for the R chart. So you can do it along, and please take your time to do it along. Please calculate, and you can go for your figure. So you can see here like Your x double bar was around 10.78, that will be the center line of x bar chart. Your r value was 0.22, so based on that my center line of x bar chart, you can see it between 10.7 and 10.75, and based on my calculation my UCL is 10.86 something, nearly to 10.86, and my LCL is around 10.6. you can see the purple and red line, and you can see that I am plotting all the x bar values. You can see that all the points are in between your UCL and LCL, so that your process is properly under control. And coming to the R chart, you can see that your D3 value is 0, so definitely your lower control limit is 0 itself, and your R bar value was 0.22, so you can see the 0.22 green line over here, and then your UCL for R bar chart around more than 0.45, so you already got the value. Then you can see the plot, and what we are doing is we are plotting the R value for each samples. So for 15 samples we are finding out the R value, and you can see that for the sample, say 8th sample, your range is out of control. So definitely you can avoid those type of observations from your list, and you can recalculate your actual R, because definitely that R value will be having an influence in your calculated R bar, and even a meager thing, but you can see that it's going out of spread. Now one more example. This is actually the calculation and things that you need to do, only that much. Very simple to calculate. Don't try to skip these type of problems. You need to keep that normal distribution table with you. That table should be available with you while you are going for examination. Now going to the second example, the following is an example of how the control limits are computed. Just easy thing, just a calculation only. So I am having a very few samples, only 5 samples I am having, and for each sample I am having only 3 observations. For each one I am finding out the x bar and R for each of them. Then I am having 3 observations, means I need to get my values. That is, for 3 observations my A2 is 1.02, D3 is 0, and D4 is 2.57. so based on that I am calculating my center line, UCL and LCL. At least please keep in mind these calculations in mind. So that is all about your control chart discussion. I will give an tutorial assignment as soon as possible, as you complete these two sessions that we discussed about control charts, and in between you can discuss on whether your doubts and things. Later we will be going to the things like process capability, standard deviation, all those things, because those are the terms that we generally used for making inferences. Okay, so thank you for listening. If you have any doubt, please ask, and you can refer your textbooks for any further details. Okay, thank you.